Hi, today we are going to look at combinations and permutations. And this is going to be the final video of this chapter. Now, I've found in my experience that students have trouble with the mathematical term combination because every single day students use a locker combination, but that combination that opens the locker is not a combination in the mathematical sense of a combination. When you try to open your locker, if you change the order of the numbers, the locker's not going to open. Also, in a locker combination, numbers can be repeated. So your combination could be 20, 30, 20, and where you have that 20 being used twice. These are completely different from the mathematical sense of a combination. Now, a combination is a series or of numbers or letters or combinations of that. And what separates a combination from a permutation is that in a combination, the order does not matter. So a lot of times you will hear these be called groups. So picking somebody first is the same as picking somebody second. They're still going to be in that group. So an example might be like assigning members of a team, or selecting players to play on a soccer field, just people that are going to go out on the field, not worrying about positions or anything like that. Permutation is when the order does matter. And a lot of times these are called arrangements, because if you switch the letters or switch the numbers, then it won't work. So like a password, the order that you put things in matters. But in both of these, we cannot repeat. So just in general, a password is not a permutation because you're allowed to use the letters more than once. But a permutation could be, the order that somebody finishes a race, first, second, and third. So those would be permutations. All right, so hopefully this helps you understand what these words are. Let's go and let's look at a few examples. All right, so this is my first example on Math Excel. And this is the way that we write permutations. So the P indicates that we have a permutation. And these numbers, the larger number always has to go first, because this is how many elements, how many things that you have that you can pick from. So if we're talking about letters, this would be 26, because there's 26 letters in the alphabet. Now, if we are picking 3 things, then that 3 goes here. So this says I have 5 things, and out of those 5, I am going to pick 3 to be in my permutation. Now, we used to have to teach the formula for all of this, but the calculators that we have now will work on this. So I just need to make sure that you know how to enter it. So you're first going to type in the 5. And then we need this P, which is under Math. And you go over to Probability. And we want option number 2, which says NPR. And then we're going to choose 3 and press Enter. And my answer is going to be 60, and that's what I type in here. Right, so this question says, from a club of 19 people, in how many ways can a group of 5 members be selected to attend a conference? So the first thing that you have to figure out is this a permutation or a combination? And right here is a key word. It says a group of 5. Now, if I'm picking people to go to a conference, does it matter which person I name first? No, it doesn't. So that means it's going to be a combination. So I have 19 people, and I need 5 members to attend. So now I'm going to once again show you how to put that into your calculator. So we type in the 19. We go over to probability again. And this time we need option 3, which has the C. Put in 5 So my answer is 11,628. So that's what I put in that box. All right, here is a different example. It's in similar style as the last example. It says, how many different two-letter codes are there if only the letters A, B, C, D, E, and F can be used, and no letter can be used more than once? All right, so letter codes. That sounds like the order matters, so that makes it a permutation. Right? How many letters do I have to choose from? 6. And how many letters do I want in my code? 2. So now I'm going to enter this in my calculator. And once I enter that in, I end up with 30. Right, this next one is a little bit more complicated, so I just wanted to show you quickly how to enter it in your calculator. I've already entered it, but I do want to point out a few things. Make sure that you put parentheses around this and then type in your 8, go get your C3. You will need to arrow out of that, kind of like you do with an exponent, to close your parentheses. And then you divide and you put the whole thing that's on the bottom in parentheses. And on this question, it says round to the nearest thousandth. So you would enter this decimal, round it correctly, and that would be how you solve that problem. So we'll look at one more example where you'll see where we set up and where we use a problem that's set up like this. Now, this question's a little bit more complicated, and I wanted to make sure that I recorded it so that you can always come back to it and re-watch it when you need to. This was one question that gave my students last year a lot of trouble, so I wanted to make sure that I have this for you to watch and re-watch. It says a basket contains 15 eggs. 3 of those are cracked. If we randomly select 8 eggs that are hard-boiled for hard boiling, what is the probability that we select each of these following? So these are 3 different problems. So we're first going to start with example A. All right, so it says, what is the probability of selecting all of the cracked eggs? So that means I am always going to be selecting 8 eggs. 3 of them are cracked. Now, this scenario, does the order matter in which I select the eggs? No. It doesn't matter, which makes it a combination. All right, so that means I have 3 cracked eggs, and in this scenario, I want to select all 3 of those. So 3C3. But that's only 3 of my eggs. So I still need to pick 5 of the eggs that are not cracked. And if there's 15 total eggs, 3 of them are cracked. That means 12 of them are not cracked. So this is how many different ways I can select all of the cracked eggs. And I need to take this out of my total ways that I can select the eggs. And so I have 15 total eggs. And out of those, I'm going to be selecting 8. All right, now I could enter this entire thing in my calculator, but I'm going to keep reusing that bottom number. So I'm actually going to set it up and do parts. So I'm going to pause the video here, put in these numbers, and then I'll come back. All right, so I put this top part in my calculator, 3C3 times 12C5, and I got 792. And then on the bottom, I took 15C8 and got 6,435. When I divided these two numbers, I got 0.1231, which I have entered in here, and it said to round to 4 decimal places. So I check my answer, and then the next question will pop up. So this says, what is the probability that none of the cracked eggs are selected? So that means I'm still going to be selecting 8 eggs, but they're all going to come from the 12 that are not cracked. So the top of this is going to be, out of my 12 good eggs that are not cracked, I'm going to be selecting 8. And I'm still going to, and on the bottom, I'm still going to have 15 that I'm going to be selecting 8 from. So my bottom number is still going to be this 6,435, but I now need to figure out what my new top number is. So this top number becomes 495. Once again, I'm going to divide it by the same bottom number, and I get the decimal point 0769. And then that takes me to my final question. And this says, what is the probability that 2 of the cracked eggs are selected? So that's similar to this top one. Out of the 3 cracked eggs, I'm selecting 2. And out of the 12 good eggs, now to get my 8, I have to select 6. And again, this bottom's still going to be 15C8. Alright, so when I figure out this top, I get 2,772 divided by 6,435, and that gives me this decimal. And hopefully this video will help. The main thing is you need to be able to determine whether a number or a scenario is a permutation or a combination. And in the future, if you get to this question and you need to come back to the video, remember, after you watch this video once, you can jump to any point in the video so you don't have to restart it all over. Thanks, and if you have any questions, ask me in class.